Hello everyone, Assalamu alaikum. In today's session, we'll be covering May June 23 and paper 2, day 3. So let's start. So that's the first question. Review a diagram and complete the following statement. The diagram has a rotational symmetry of order and we're supposed to write what's the order of rotational symmetry. Now for that, we need to understand what does rotational symmetry lie or means. So whenever the object has the same shape when it is rotated throughout 360 degree, rotating it throughout 360 degree and has the same shape, that counts as one order. So how many orders of rotational symmetry does this particular shape have? For that, let's say take a rectangle similar to the one that we have here, or a square, and then let's say for reference we can shade it like this. And now, if we rotate the object that we have a look at the rectangle that we are rotating. We'll rotate it 360 degrees. So we rotate it, that's 90-degree rotated, but it's not the same object, the same shape. So we have rotated 90-degree, but it's still not the same shape. We rotate it further, still not the same shape. Have a look at the shaded boxes, then and then we finally have a same shape at 180-degree rotation. So I've rotated it about 180 degrees because the starting point was this. So if you mark the starting point as well, this was the starting point. Yeah, so and let's rotate it again. So we rotated at 90 degrees, we did not get anything. And then we rotated it 180 degrees, we get the same shape. So that's order one. 270 degrees rotated, still not the same shape, and 360 degrees rotated. So we have the same shape again. So we got two orders. So the order of rotation symmetry here should actually be two. Because we're getting the same shapes twice when we're rotating the shape throughout 360 degrees. We're getting the same shape twice. On the diagram, draw all the lines of symmetry. So we're supposed to draw the possible lines of symmetry that we may have here. Okay, so to draw the lines of symmetry, let's erase this up. First part was so this is going to be the first line of symmetry because it breaks the image into two equal halves. And the second line of symmetry that we may have will be this one. There won't be any vertical or horizontal lines of symmetry, completely horizontal or vertical, because the issue with that is if I have a line of symmetry like this, I do not have this as the shaded. I do have this as shaded, but do not have this as the shaded. Similarly, I do not have this as the shaded. And the same issue with a vertical line of symmetry here, sorry, with a horizontal line of symmetry is that I have this shaded, but I do not have this box as shaded. So it's unshaded. That does not mean it would be a line of symmetry. Hence, the only two lines of symmetry would be the ones that are drawn. So this is done. Let's move on to the next question. So a film lasts for, that's the duration, 2 hours and 50 minutes. The film ended at 23:05. So this is a 24-hour clock. This means this is PM. Find the time when the film starts. So we have to basically go back in the time. We have to subtract So we are at 23:05 and we have to travel backwards 2 hours 50 minutes. So let's just do 2 hours first. So we are assuming we are using a 24-hour clock. So let's just say 21:05 and then we go 5 minutes back. So we are 21. And since we broke the 50 minutes into two parts, which is 5 minutes and 45, so you'll have to go 45 minutes back more and we'll be at 21:05. So that's 8:15 p.m. And that's a final answer. So it's either 21:05 or if you write it in 12-hour format, it would be 8:15 p.m. That's a correct answer. So you just had to find the time at which the film starts, the beginning time of it. Let's move on to the next question. If you're given a cuboid and we're supposed to find the total surface area. So a cuboid has 6 surfaces. And in other words, it actually has 6 rectangles. And the area of a rectangle is length into width. So we're supposed to just manually find the areas of all the 6 surfaces and we get the total surface area. So it's going to be 2 times of length into width plus length into width or height. Like there are just 3 lengths you can work around with. We can just do it without the formula as well. With manually taking all this. So let's say if you're taking the top and base. So top and base will go. So it's going to be, the base is a rectangle that's going to be 8 into 3. And 2 times of that because we have the same scenario at the top as well. And then you can take the front and the back. This side, this is the front, and the back would actually be this one. So this is 8 and this should be 5. So we have 8 multiplied by 5 times 2 because there are 2 surfaces of the scene. And lastly, we have the side laterals, we could say right and left. So this is the right one and this is the left one. So it's going to be 5 into 3. Length into width, the formula for rectangle, and there are 2 surfaces. So right, left. Yeah. So these are all the 6 surfaces. So we can just add. This is going to be 48 times. We add them up to find the area. It's going to be 80, and this is 15 times as 30. When we add them up, we should be getting 158 actually. 258. Yeah. So the final answer is actually, hold up, 48 plus 80 plus 30. Yeah, that's the final answer. Is 158. My bad if I said it's going to be 250. It's actually 150. Yeah, so we'll write the final answer and move to the next question. We have an expression here, algebraic expression. We are supposed to find the value of u when u is this and t is this. So we'll just plug in the values of u and t. U is 4. So that's 4. 9.8 times t, and t is -7. Then we use the calculator. So it's 4 negative 9.8 times -7. That's going to give us 3.6 as the value. We're supposed to simplify the this expression, so the best way is first to write it in a fraction form, which is the same thing as being divided. And then you need to have some basic indices knowledge here to solve this further, that whenever you have let's say you have n over n, and you have the powers as a and b. So when they're being divided, so it can be written as, can actually be written as a minus b. So the powers get subtracted when the bases are being divided and they're the same number. Now the important thing to note here is that I've used the same number n and s. So n and n. So if I had used x, so I would be x and x. So let's say it was xx would be the same number. So when you have the same base number, this number is the base number, and you have the same base number and the terms are being divided, the powers actually get subtracted. So using the same analogy or logic, you could say that it should be written as the bases are same here. So the only reason we are allowed to do that is the bases are same and the terms are being divided. So the power should actually get subtracted. Hence, it's going to be 3 to the power 6. If the terms have the same basis and they will be multiplied, you would have actually added the powers instead of subtracted. Yeah, those are the two rules of indices. Question 6. At the end of the day, a shopkeeper has 12 tins of cat food left. He has how many? 12 tins. This is 3/3 of the number that we had at the beginning of the day. What is 313? 3/3. It's actually 313. What is 313 of the number here? It's 330 of x, like the total number of tins for cat food we had. The 3/13th of that is left at the end of the day, which is equivalent to 12. This is the expression that we need to make after reading the first two lines. If you're able to make this expression, then you're good to go with this question. There's not much difficulty with that, this type of question. Let's read it again. At the end of the day, a shopkeeper has 12 tins of cat food left. So that's the amount of tins he has at the end of the day. This is 3/13th of the number he had at the beginning of the day. It's 3/13th of something that was at the beginning of the day. This is at the beginning of the day. It's x, beginning of the day. We do not know now. Calculate the number of tins he had at the beginning of the day. So we are actually supposed to solve for x here. By the way, of implies it's actually being multiplied. So I'll just write it like this. And then we can take the 13th on the other side. So it's going to be 3x times 12 into 13. And then the x is equal to 12 times 13 divided by 3. It's going to be 52. So the amount of tens that he had at the start of the day was 52. And when you check out the 3/13th of 52, you cross-check your answer and to understand this logic further. The 3/13 of 52 is actually coming out to 312. So logic is perfectly fine here. We have done it absolutely right. Okay, so the next question, a spinner has 5 sides. We have a spinner with 5 sides. Each side is painted with a color here, red, blue, green, yellow, and orange. And we have the relevant probabilities of the spinner landing on each color. So we have 4 of the colors probabilities given, but we are not given the probability for orange. We are supposed to complete the table. This is relatively straightforward. The total probability of any particular event is 1. So I'll just do 1 minus the probability, all the other probabilities. The remaining probability has to be the probability of getting the color orange. So that's going to be 0.11. Second part. Dan spins the spinner once. Okay. Find the probability that the spinner lands on red or blue. This is your main expression. So you're spinning only once. Dan is only spinning once, and you're supposed to get red or blue. So first thing to note here is that whenever you have or in probabilities, that means you're supposed to use the plus sign, the addition sign. And now the probability of getting the red was 0.3 since he is only spinning once, so it's straightforward, right? And for blue it's actually 0.16. So that should give us 0.46, or you can even write the fraction form of it. That's also fine. That's your answer for this part. So the only thing we need to make sure is that or actually means add, addition, and means to multiply in probabilities. Let's move on to the next question. So we are supposed to tell the single transformation that maps A onto B. So A is the object and B is the image. So we are supposed to go from A to B. What has happened from A to B? That is what we're supposed to find out. So the best way to do this transformation question is when you're trying to figure out the type of transformation is to use an elimination method. You eliminate in a particular order to figure out which type of transformation is it. You go with enlargement, and this is clearly not enlargement because the size has not changed. For enlargement, the size of the object or the image would have changed, would have differed actually. Translation. It's translation or no, it's actually not translation either. It's not been, the object has not been dragged vertically or horizontally. It has actually somewhat changed its structure or has rotated. Now for the third portion, we go for reflection and rotation together. Once you have figured out the enlargement and the translation, so we know it's either rotation or reflection. Now for that, the final test that we could have here is to draw lines to figure this out if it's going to be reflection or rotation. Okay, now so we'll have to join the corresponding points here in order to check whether it's rotation or reflection. So this point is going to be here. It's going to be this point, and we already have an intersection between the lines. It's going to be this. Now, how do we decide if it's reflection or rotation? It's actually rotation, and the reason for that is found an intersection between the lines. So it's actually, if you do have an intersection, it's actually rotation. And for reflection, it would have been no intersection. The lines would have been parallel or overlapping, but there would have been no intersection. So we have managed to figure out this is rotation. So let's write that down. So this is the rotation. And now we need to write two more things in order to get the 3 marks. So we have gotten 1 mark. We still need two things: the angle of rotation and the degree of rotation. Sorry, center of rotation. The angle of rotation and the center of rotation. So for the angle of rotation or the degree of rotation, this is straightforward. Let's just erase all this for now. We do not need all of this. Yeah, so for the angle of rotation, if I have a horizontal line here which has become vertical, so I have a line that has become vertical, so this angle is how much? It's actually 90 degree. So it's actually 90 degree, and it's gone in this direction. So it's actually 90 degree clockwise. So that's your second mark for writing the direction and angle of rotation. That's 90 degree clockwise. And the final thing we need to write is the center point. Okay, so for the center of rotation, there are multiple methods that you can work around with, but the easiest method is using a tracing paper. You keep a tracing paper, you keep a pencil at a particular point, and then you rotate it to check if that's the center of rotation or not. So you can use it using a trial and error method using a tracing paper. The center points for this rotation 90-degree clockwise is going to be the origin itself. This is the center of rotation for this. And you can also do it without the tracing paper using the perpendicular bisector method. When you join the 2 points, two set of points, and you make the arcs using a compass, wherever the two perpendicular bisector meets would actually be a center of rotation. For the next question, we have a distance time graph. So we have distance on the y-axis and time on the x-axis that shows information about Kai's journey from home to the office. It's going from home to the office and starting at 10 in the morning, that's 10 a.m. Calculate the average speed in kilometer per hour for Kai's journey from home to the office. So you're from home to the office, so this is the entire portion that's drawn. You're supposed to calculate the average speed. So average speed is actually total distance over total time. That's a formula for average speed. So you need to calculate the total distance. The total distance is 0 to this. What's the value that we have here? It's going to be 65. Is exactly in the half. Each box is representing one unit. So that's 61 and similarly this is going to be 65. So total distance traveled is 65 kilometers. Make sure of the unit in this chapter. It's very important. The unit remains the same. So you have kilometers with hours and you have meters with seconds. Usually that's the pattern. So total distance is 65. Total time traveled would be from 10 in the morning and he reached about at 12. Yeah. So that's 2 hours because we have to write the time in hours. So that's 2 hours and it's going to give us 32.5. That's your average speed. 32.5 kilometer per hour. When Guy arrives at the office, he finds his meeting is cancelled. He immediately returns home. He's going back home at a constant speed of 50 kilometer per hour. Complete the distance time graph to show his journey. So it's supposed to draw the graph, complete the graph when he's traveling back home because his meeting cancelled, so he's going back home. So what we know so far is that when he's going back home, his speed is 50 kilometer per hour. And we know the basic formula is speed is equal to distance over time. We do know the distance as well. The distance would obviously remain the same. From home to office is 65 kilometers. So from office to home would also be 65 kilometers. What we do not know is the time, but we can work around by manipulating, by making time the subject. So that's going to be distance over speed. That's 50 divided, actually 65 upon 50. So that's going to give us 1.3 in hours. That's because we have kilometer and kilometer per hour as the two other units. So we have 1.3 hours in time. And now the issue is that first we need to convert this as to how many minutes is this in minutes. Because on the x-axis, we have to calculate it upon minutes. So that's how we'll mark the value. So 1.3 hours in minutes. So let's just do for 0.3 hours because we do know that this is comprising of 1 hour and 0.3 hours. 0.3 hours. So basic conversion we can do is that 1 hour has 60 minutes. So how much would 0.3 hour have? That's x. And then we can just basically cross multiply them and solve. So we'll get the value of x to be 0.3 times 60, which is equal to 18 minutes. So 0.3 hours is 18 minutes. So actually, in other words, this is equivalent to 1 hour, 18 minutes. So now we can draw the graph. We do know the time. We have everything available. We have gotten the speed, distance, and time, so we can just draw the graph. So it'll be going back, so the line would actually be coming downwards. Yeah, so we'll be starting the graph from this point, but we do need to know at, so since he's going back home, so he's probably going to arrive here, but at what time? So what we calculated is that it takes 1 hour and 18 minutes from the time that he leaves office. So assuming he leaves at 12, so it's 1 hour, 18 minutes would be 1, 1:18 p.m. or 13:18. So now for that, we need to understand the scale here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at 10 and 10, that's 20 boxes and 1 hour between them. So that would mean that we have 13:30 here in the middle. So 30 minutes being represented by 10 boxes, which means that 30 divided by 3. So you have 3 per box or 3 minutes per box. 3 minutes per box. So we'll have to go at 1:18 p.m. So let's just count for that. This is 103, 106, 109, 112, 15, 16. 16 is going to be this value. So let's just raise all the other values. This is going to be the point at which we will arrive at as well. So we're going backwards and the graph would be looking something like this. That's the complete distance and graph of going backwards. Workout. You're supposed to work this out without using the calculator, but obviously you can use the calculator afterwards to check the answer as final answer. So first, let's just work this around. We're supposed to show all the working and give the final answer as a mixed number and it's so let's just work around with all of the requirements one at a time. So we have both the numbers actually in mixed number form. We need to convert them first up. So the conversion rule was that the denominator remains the same, but for the numerator, you do 12 into 5. And whatever the result you get, you add that with the number as numerator. Similarly, here it would be 4 remaining the same, and we do 4 into 2, and then add up to 1. This is going to give us 60 plus 1, that's 71 over 12. And this is 9 over 12, 9 over 4 actually. And then we can cancel them down. So that's 12 fours are, 12 threes are, and then we can further multiply them up. So that's 71 times 3, that's going to be 213. My bad, actually, they cannot be cancelled here. We cancelled them wrong. So let's just delete that because we have a plus instead of a multiply. We do not have a multiply or a divide that we can cancel numbers here. We'll actually have to take LCM here to solve this further. So we'll just take 12 and 4. The common denominator for this should be 12, or the least common multiple should be 12. So we'll just multiply 4 times 3 because 4 into 3 also gives us 12. I will also do it with the numerator as well. We'll have to do it with the numerator as well. So that's going to give us 71 over 12. Make sure you do all of this instead of using the calculator because you're supposed to show all the work. So 71 over 12. And this is going to be 9 times 3 is 27. And that's 27 over 12. It can also be written as a single denominator, which is the same thing as 98 over 12. And when you further simplify them up in the table of 2, so that's 249, 2 times 49 is 98, and that's 6. So that's the most expressive form, that's 49 over 6. Cannot be further simplified, but it's not the final answer because we need to give it as a mixed number. So to convert to a mixed number, the denominator remains the same. Now we will need to times it by 6 to some number till we do not exceed the number that's in the numerator. So we do 6 times 8 because 6 times 8 gives us 48 and the remainder will be 1. So that's your mixed number answer for this particular part. The next question is of sets. We are supposed to complete the Venn diagram using the information. So the first set is actually the universal set that comprises the entire rectangle. And then you have two subsets in the universal set, the set P and the set Q. And you're supposed to complete the Venn diagram. So you just have to mark which set will be carrying which alphabet here in this or which element particularly. So the easiest way to do this is to first look out for the common intersection between the set P and Q because that would be this particular. So let's look out for the common elements. Do we have any common elements? So let's start with P. Is do you have A? No. Is B common? No. Is E common? Yes. We have E common, so let's just write that. Then we do have a G common as well actually. And then L is not common, R is common again, so we'll write R. Those are the common elements. Then you look out for elements in P only. So elements in P only would be this ABL. So that's ABL. And then finally we look out for components in Q only. So that's MOR, MO, T, and Y. Now we need to look at the universal set and see have we covered all the alphabets, because if there's no any alphabet in the universal set that's not in P only, Q only, or intersection, that means that would be lying in this region, the neither region. So let's check for that. A is written already, B is written, E is written, G is written, L is written, M is written, O is written, R is written, T is written, Y is written. So we have incorporated every element. That means we have nothing here, a zero or nothing. None of the elements lie in the neither category. So fill the Venn diagram. Let's move on to the next part. We're supposed to shade the region A complement intersection B. So the best way to do such type of question is to label the regions always. Give them random numbers, just label the 4 regions that we have. The 4 different regions possible in this diagram are these. The neither region, the A only region, the intersection region is 3, and the B only region is 4. Now we need A complement. So what should be A complement in this? The complement A would mean universal set minus A. Now the universal set we have is for 1, 2, 3, and 4 because those are the 4 numbers that I put. And the set A would have just 2 and 3. So you subtract 1, 2, 3 and you subtract 2, 3, you'll be left with 1 and 4. A complement would mean everything else in the universe except the set A, so that's 1 and 4. And B is the set 3 and 4. The circle of B. If you look at the circle of B only, you'll realize that it has the numbers 3 and 4, so the elements are 3 and 4. Now what we do need is the intersection of both, which is straightforward. We get 4 as the intersection. So that's the intersection. And that is the region that should be actually shown. That's your answer for this part. Position vector of A. We have a position vector of A and B is given this. So now what's a position vector? First things first is is a vector that starts with the letter O. So it's actually OA. The vector OA is actually the column vector O is actually 5 and 3. And position vector is just the coordinates of the same. So another way of writing this would be that A has the coordinates 5 and 3. That's your position vector. Then we have the vector BA, and we're supposed to show that these lines are of what? Magnitude. When you see modulus in vectors, it means magnitude or length. The length of the vector OB, this implies it's a vector OB, is actually 5.1 correct to one decimal place. We're supposed to show that. But we do not have the vector OB. How are we supposed to find the length of that vector? So first thing is, what is the vector OB? We need to figure that out. And using the information we have in the question, we have BA, and we do know that BA is basically OB, actually OA minus OB. The vector BA is actually the vector OA minus OB. Why is that? Because the formula is usually final minus, or you could say last minus initial. Or another word would be second minus first. That's the formula you have usually. For any vector, the position vector second minus first would be in the order of appearance. So A came second, so that's why the position vector of A minus the position vector of B, which is first, second minus first, or last minus initial. Either ways, you have BA available as 4 and 8, and you have OA also available as 5 and 3. We just figured that out. That position vector means that the vector is starting from the origin, which is 4, so it's represented with the letter 4. And for OB, we do not need that. We do not know what OB is. We need to figure that out. So we'll make OB the subject by taking it on the other side, and we'll bring B on this side. So 4 and 8 would get subtracted because they were positive on that side. So OB comes out to be 5 minus 4, which is going to be like this, the x component with x component, y component with y component. So that's going to be 1, and 3 minus 8 is going to give us negative 5. That's your vector OB. Now to find the length of OB vector, straightforward, just going to be the formula is x squared plus y squared. So it's going to be 1 squared plus negative 5. Always use brackets when squaring, so you do not make the plus minus mistake. So that's going to be 26. So in decimals, it's going to be 5.1, which is short. That is what we were supposed to show. So yeah, so it has been shown that it is 5.1 correct to one decimal place. Correct to one decimal place in this sense because the answer when you calculate the under root of 26, you're actually getting 5.099 on my calculator. And when you take the rounded off to one decimal place, you're getting 5.1, which is what we were supposed to show. Okay, we're supposed to calculate this using a calculator, so this is straightforward. So it's going to be square root of 42. Then you add a plus separately from the square root, and 3 to the power 0.4. That's going to give us 8.03. So 8.03, that's your answer. And this, by the way, is not the answer for this question. Let's move the arrow for that. Let's separate that forward. Okay. So we have right 0.581 as a fraction. We have recurring decimal. So two numbers are recurring, 8 and 1, that can be seen or observed using these symbols on them. And we're supposed to show all our working to give the answer in simplest form. So first thing is we write the number as it is, and it's going to be like this since it's recurring. It's a recurring decimal, so it's going to be like this. And now, first thing we do for step 1, we could say would be that we bring the number which is not recurring before the decimal place, so like on the left of the decimal. So this is the number that's actually not recurring. So we'll have to bring it on this side of the decimal on the left. How do we do that? By multiplying by 10. So we'll actually multiply by 10. And when you multiply by 10, you're actually gonna move the decimal place one place forward, so it's gonna look actually like this. For the second step, what we need to do is that we actually need to now the two recurring numbers need to be before the decimal place on the left. So how do I make the 8 and 1 before the decimal place is I'll have to move 1 and 2. 2 decimal place, and if I'm doing from here, so it's 1, 2, and 3 decimal place. So either ways, I'll have to multiply it with 1000. The initial number with 1000, or if I'm doing for this number, I'll multiply it with 100. So I'm using the original number, I'll have to multiply it with 1000 because 1, 2, 3. That's how the recurring number would actually be before the decimal place. And it would actually become 581.81 as you move the decimal place three units forward because of the three zeros. And now we have the value for, let's say this was x. So we have the value for 10x. This is the value for 10x. And this is the value for 1000x. Now let's say if I do 1000x minus 10x, I should get 90x. But in the same terminology, so if you use the numbers that we had, 581.81 minus 5.8181, and we use the calculator for this. So getting 576, and then x is going to be 576 divided by 90, as 90 goes on the other side, which is 576 divided by 90 is going to give us 32 over 5, and that's our final answer because we're supposed to write it in the simplest form. Hold up, I think we have made a mistake here slightly. This was supposed to be 900, actually not 90, this one, because it's 1000 minus 10, not 1000 minus 100. So it's supposed to be 990 actually, not 90. It's supposed to add the 990 here, so this is incorrect. Let's just correct this real quick. It's going to be 576 divided by 990. That's going to give us 32 over 55, and that's your simplified fraction as the final answer. Question 15. The number of trees in a forest is decreasing exponentially. So now, exponentially, whenever you have exponentially, it means you're referring to a case of a compound interest. Usually, an increasing decreasing would imply the sign. If for increasing, you usually use plus, and for decreasing, you use minus. So at a rate, decreasing exponentially let's read further and then we'll discuss the formula. At a rate of 1.75% per year, 11 years ago, there were 980 trees. Calculate the number of trees in the forest now. Give your answer correct to the nearest. So, the basic formula that we have usually is that present value and final value. So, let's say we have the present value or the principal as in a compound interest, it's usually this is the formula that you use. Final value is equal to present value to 1 plus interest rate to the power n, which is the, or the power t, you could say the power t, which is the time years. But this formula works perfectly fine if the examiner said exponential increase. But it's actually not exponential increase, it's actually exponential decrease. We'll have to use the minus version of this formula because of the decrease, and this is going to be time in years. So, do we know the ending value or the final value? We do not. We are supposed to calculate that the current value of the what is the value number of trees. So we do know the present value was 980 trees, and 1 minus the interest rate, which is 1.75%, or you can write the decimal value, which is going to be 0.175, and time in years is going to be 11. And then you can just use the calculator. So it's 980 bracket open 1 minus 1.75% whole thing to the power 11. The bracket to the power 11. So that's going to be, the answer is going to be 807. And since we are supposed to, so we are getting 807.19, but we're supposed to round it to the nearest integer. It's just going to be 807. Question 16. The volume of the cylinder is 1970 centimeter cube. The height of the cylinder is this. Calculate the radius. So what we know so far, let's read it one step at a time. So volume of cylinder is actually 1970 and height is 12.8. Radius we are not, we are supposed to find. We already know the formula for volume of cylinder is actually pi r square h. Using the formula, we can figure out radius, but for that, we first need to plug in the value of height, which is 12.8. And now, notice we have only single variable r. Pi is not a variable, pi is a constant. So that's just some value, which is 3.142. So we can find out radius. So radius is r square is going to be 1970 upon 12.8 pi. And then you can take the square root of the entire thing. So it's going to be square root 1970 12.8 pi. And then the answer for this that we are getting is 6.99, which is equivalent to 7. So the radius is 7. Rearrange the formula to make m the subject. So we're supposed to make m the subject. So keep an eye on m. We need to isolate it. Even though we have two terms of m, but we do need to bring them on the same side and everything on the other side. So first thing is we remove the fraction by taking the m on the other side and multiplying it. So it's going to be Rm, and this is going to be 2 into, we need to open this bracket up so we can separate the n and k. So it's going to be 2k, and the m goes on the other side. It's going to be 2m equals to minus 2. So that's the correct way of solving. You're bringing the m's on the same side, especially when you have more than one variable terms for the variable that needs to be need subject. So m was supposed to be need subject, and you have two terms for m. Now what we can do is that the best part is now when you do have both the terms on the same side, you can take out common, and that's how you make the two terms into a single term. And now since r minus 2 is being multiplied, it will go on the other side and get divided. So it's just going to be this. So the final answer is minus 2k over r minus 2. That's your final answer for this part. Y is inversely proportional, so that's 1 over to the cube root of x plus 5. That's the situation we have, so that's going to be y equals to k over cube root of x plus 5. Inversely proportional would imply that's 1 over something, k over something. If it was directly proportional, it would have been k times something. Now we do know the values of x and y here, so we can plug them in. Y plugged as 3, and you can use the value of x and y to find out k. So k is going to be cube root x is going to be 3 plus 5, 12 equals to, so that's 8, and cube root of 8 is actually 2, because 2 cube is 8, and k is 2 times of 12, which is 24. Now when you do have the value of k, you can place it back here. and it will look like 24 over x plus 5. And now final requirements to find y when x is 22. Now we can just plug in the value of x here, find out y. X is 22, so that's 24 cube root 27, which is going to be 3. Cube root 27 is 3, 24 divided by 3 is 8. So the value of y should actually be 8. We're supposed to solve the equation, so we have a quadratic equation here. You must show all your working and give your answers correct to two decimal places. So now there are multiple ways how you can factorize or solve a quadratic, but how do you know which one to use here is the real question. Now, the last phrase, correct to two decimal place, is actually giving you a hint that you have to use the quadratic formula, because only then you are more or less likely to get the answers in decimals or non-exact answers for that matter. You get usually using the quadratic formula. So you go for the quadratic formula straight away instead of trying for middle term breaking or other methods. So the formula is, let's write down the formula, minus b squared minus b plus minus under root b squared minus 4ac over 2. That's the quadratic formula that we have. Let's write down the values of a. A is 1, which is the coefficient of x squared. B is the coefficient of x with the sign, so that's plus 5. And c is the number without the variable, so that's -7. So that's going to be 5 plus minus. We have to show the working. We are supposed to show the working, so do not skip out on working and show each step as you put in the values. 4 times a times c upon 2 times a. And now we can further solve this without using the calculator. We can use further simplification. That's going to be minus 5. And 5 squared is 25. That's 4 times 7. That's 28 times 1. That's 28. And the signs would actually be plus because of the minus minus. So that's plus 28. The denominator, you just have 2 into 1. That's just 2. And then we have minus 5 times 53. And then you can use the calculator to check the answer. So that's minus 5. And first it's going to be for plus, and then you can do the same thing for minus. So you're getting two answers. So we'll do break it into two parts. So it's going to be minus 5 plus under root 53 divided by 2. And it's going to be minus 5 minus under root 53 divided by 2. So the answer we are getting from this is 1.14. And when we do the minus version of it, we're getting 6.14, negative 6.14. So the answers are going to be 1.14 and negative 6.14. Those are your final answers, correct to two decimal places. So I basically rounded them off to two decimal places, both the answers, because the examiner asked us to do so. Next, we have functions. Fx is given, dx is given. We are supposed to find f. X plus 2 is your input. Give your answer in its simplest form. So you're just changing the input. Input is the part that's inside the bracket. When you change the input, it just changes accordingly or proportionately with x. So wherever you had x, the input would change to whatever the new input is. So to sum it up, it's just going to be 6. Let's leave a bracket here. Yeah, so we had x here, but now the input is x plus 2, so we're just going to write x plus 2. and then just solve. So that's 6 plus 12 minus 7. That's 6x plus 5. That's your answer for this question. The next part is asking us to find what is this sign for. It's not a derivative sign, it's actually a inverse sign. We're supposed to take the inverse of fx function. So first step one is that we write it instead of fx, you write y. So that's y equals to 6x minus 7. Step two is you try to make x the subject. So that's y plus 7 goes on the other side and goes to 6x. Then you divide the 6 on the other side. And finally, you have made x the subject. We write this as x equals to y plus 7 over 6. Third step is that we replace the x with what we are supposed to find, which was f inverse of x. And we replace the y with x actually, so that's x plus 7 over 6. So final answer is actually x plus 7 over 6. That's how you find the inverse of this. Next, we have find x when gx is equals to this. So gx function is x to the power negative 3. That's x to the power negative 3 and f22. But f22 would mean I'd have to plug in the value as 22 instead of x, and the entire function would just come along. So this 22 is because of the input. Otherwise, we have copied the same function, except for the value of x, we have placed 22. Now, using the calculator, we can figure this out. 6 times 22 minus 7, that's 125. Which can be expressed as 5 cubed. 125 in the powers of 3, that's 5 cubed. And x to the power negative 3 is just one. Another way of writing as 1 over x cubed is the same thing. And then when we take this on the other side and 5 on this side, if we swap their places, so it's going to be something like this. And then we can take cube root both sides. So we'll be just left with x and we'll be left with cube root of 1 is just 1, and for 5 cube, cube root would mean cube root and cube cancel out, so we're just left with 1 over 5. So the final answer for this question should actually be 1 over 5 or 0.2 in decimals. Okay, next we have the simplification part. Now, usually in simplifications with fractions, we try to solve the numerator and denominator separately and then merge them up. So for the numerator, let's just deal with this one problem at a time. We have a quadratic equation. We need to simplify this, but we cannot take common. Algebraic identity is not possible. Let's try for middle term taking. So we have the number 2 and 12. 2 and 12 make 24. We are supposed to look at the factors of 24 that add up or subtract to get the middle number, which is 5. 1 into 24 does not help. 2 into 12 does not help. 3 into 8 does help. Because 8 minus 3 gives us 5. It's going to be 2x squared plus 8x minus 3x minus 12. And then we can take the 2 common and the 2 pairs and make pairs and take common. So that's 2x can be taken common out, x plus 4. This bracket should be x plus 4 as well. And we need to take minus 3 common here. So further, it's going to be x plus 4 and 2x minus 3. That's your simplification or factorization of the numerator. Now for the denominator, it's going to be 4x squared minus 9. That is what the question said. We cannot take common, but yeah, we can apply the algebraic identity, because again, what we do see is that we see two terms with a minus in between them. And they both are perfect squares or can be actually brought upon in that condition as per requirement. So 4x square minus 9 would actually allow us to apply the identity. How so? First, we need to write the entire term in the whole square. So this is very important to understand here what's wrong in this expression currently. So in order to bring it or apply the identity by the way was a square minus b square is a plus b times a minus b. Now to apply this identity, I'll have to first bring it in the right condition. It is not in the right condition. The right condition requires you for both your entire term to be in the power of 2 and similarly entire term b to be in the power of 2 with a negative in between. So we do not have the power 2 here on 4. We have the power 2 here on our x only. So we need to somehow think of a way we can have the whole power 2, and that would be just 2 square and x square, and that's just 2x whole square. This 2 square is 4, and then because indices allows you to, when the terms are multiplied, indices allows you to write a common power like this on a bracket. It's acceptable. Similarly, for 9, if you have to write it in a power of 2, it's going to be 3 square. You have the minus in between. We can now apply the identity. So it's going to be a plus b, so that's 2x plus 3. And a minus b, that's 2x minus 3. That's your simplified form for this. Now we can merge them up. So it's numerator over denominator. Numerator, we had this. Yeah. So it's going to be x plus 4, 2x minus 3 for the numerator. And for the denominator, it's actually 2x plus 3 and 2x minus 3. Now, what do we know? Notice? Is there any further simplification? Yes, there is. We can see the 2x minus 3 and 2x minus 3 can be cancelled out. So we are just left with x plus 4 over 2x plus 3. That's the most simplified form for this answer. And that is the answer that is going to get you the 4 marks. So we use the technique of solving the numerator, dealing with the numerator separately and dealing with the denominator separately. So that way we do not merge them up and get confused and can do the working separately. The next question, these are the first 4 terms of a sequence. We have a sequence given here, the first 4 terms of that. And we have the nth term formula for that sequence as well. Obviously, we do not know the values of A and B, so it's an incomplete formula given, and that's the values of A and B that we are supposed to figure out. What should be the values of A and B that we according to this sequence and according to these 4 terms. So ideally, if this is the nth term formula, which is 1 over 4 n cubed plus a n square plus b n. So this should work for all the terms of this sequence. And we already have the first term as 2.75. Or if I let's say like this, the first term is actually 2.75. How do you get the first term? When you plug n as 1, because if we take the n index, it's going to be 1 here, 2 here, 3 here, and 4 here. So n is 1 for the first term. So let's just plug n as 1 here. A times 1 square, and that's going to be b times 1. And this should be equivalent to this value, the first term, which is 2.75. When we simplify this further, we get that 1 over 4 plus a plus b is equals to 0.75. And a plus b is equals to 1 over 4 goes on the other side, so it's 0.75 minus 1 over 4, which is 1 over 2. So we have managed to find one equation using n equals to 1. Similar logic, we'll use n2 for the second term. Second term we know is actually 6. So we'll use n as 2 here. So that's 2 cubed plus a times 2 plus b times 2 equals to 2.75. And then we can use the calculator. So that's 8 and 8 on 4 would give us 2. 2 plus 2a plus 2b equals to 2.75. And upon further simplification, this is going to be 2a plus 2b and 0.75. That's the second equation we have gotten. So now we have two equations with how many variables? Two variables. So how do you solve two equations with two variables? What's the method that we use? Simultaneous. We'll solve them simultaneously. We have the first equation and the second equation. First thing is we take any of the one equation, any of the two equations, and make one variable subject. I'll work around with equation 1 here. So a plus b equals to half. So I'll take the basic substitution as half minus b. A equals to half minus b. That's my substitution. Now I'm going to place that in the second equation. So that's going to be 2 times a is 1 over 2 minus b plus 2b equals to 0.75. We could have used the elimination method here as well. The substitution and elimination, both methods are acceptable. This is going to cancel out, so this is going to be 1. This is going to be 2b plus 2b equals to 0.05. Yeah, the b shouldn't cancel out, so we have probably made a working mistake somewhere in our working. So let's just check. Yes, this is not supposed to be 2.75 because N2 would give us the second term, which is actually 6. It's supposed to be 6 actually, not 2.75. Let's just correct this. 6, 6, and then 6 minus 2 is going to give us 4. And this would be actually 4 as well. This is the second equation, and the second equation just got some changes, so that's 4. And initially, we'll have to correct the first equation as well. Yeah, for the first equation, here's the mistake. So let's just correct this. This is not going to be 0.75. It's supposed to be 2.75. And when 1 over 4 goes on the other side, so it's actually going to be 2.75 minus 1 over 4. So it's going to be a plus b times 2.5 equals to 2.5. That's going to be your first equation. And similarly, we'll edit this here. This is supposed to be 2.5. Yeah, so power of this is going to be 2 because it was an square. So that's going to be 4a instead of the 2a. And this is going to be 4a. And we can further simplify it, but let's just leave it like that for now. So it's going to be 4 times a plus 2b. So let's rewrite this again. Yeah, we have the two equations. A plus b equals to 2.5. That's the first equation. This is the second equation after correcting for the errors. And then we solve this simultaneously. We make a substitution introducing the first equation. So we substitute it in the second equation. And solving this further, this is going to give us 10. This is going to be 4b plus 2b equals to 4. That's going to be negative 2b, and 10 goes on the other side. So that's going to be negative 6. And b is supposed to be negative 6 divided by negative 2, which is going to be positive 3. that's your answer as the value for B. But we do need the value for A as well, so we'll just substitute it anywhere. So best place to substitute is with the substitution. So just use the substitution here. That's A is equals to 2.5 times minus B. And we do know that B is actually 3. So that's just going to be 0.5. So A is just going to be 0.5 or negative 1 over 2. Both are acceptable. That's the final answer to this question. Okay, so the next question, a train travels between two stations. The distance between the stations is, so we have distance as 220 kilometers, correct to the nearest kilometer. This is a question of limits of accuracy or upper bounds and lower bounds. So correct to the nearest kilometer when there is no number, so you assume the number to be 1, so you have 1 kilometer as accuracy, you divide it by 2, so you get error which is 0.5. So error is 0.5, yeah, 0.5 kilometer. The speed of the train is 125 km per hour, correct to the nearest 5 km per hour. So the error here should be 5 divided by 2, that's 2.5 km per hour. That's your error, upper or margin of error. And then you are supposed to calculate the upper bound for the time the journey takes. Give your answer in hours and minutes. First, we need to know the basic formula, that's speed, that connects the speed, distance, and time as this. And then we need to isolate time because we're supposed to find time. So we do know that it's actually going to be times equals to distance over speed. That's the formula that we're going to use. And now we need to understand, we need the upper bound for time. So what do we need the distance and speed to be? Do we need the lower bounds? Do we need the upper bounds? How do we decide that? So we'll actually need the upper bound for the distance and the lower bound for speed. Because in a fraction, when you have division of a formula like that connecting, so the number in the denominator is the one that when you increase that, your answer actually increases. When you decrease that, your answer actually decreases. For the denominator, that's the numerator. For the denominator, it's actually vice versa. For the denominator, if you decrease your denominator, your answer actually increases. You can even check that with random values. And vice versa, when you increase the denominator, your answer actually decreases. So according to that logic, we actually need the upper bound for distance and the lower bound for speed. So upper bound for distance would be, since distance was 220, and for upper bound we actually add error. Error was, the error that we found for distance was 0.5 kilometers. So that's 0.5 added. And for speed, it's going to be 125 was the value, the original value. And for lower bound, we subtract the error, which is 2.5 for speed. And then we just find the answer using the calculator. So this is going to be 220 plus 0.5 divided by 125 minus 2.5. So that's going to give you 1.8, which is in what unit? It should be in the unit of hours only. Because you had the distance in kilometer and you had the speed in kilometer per hour. So the kilometer cancel out, and what you're eventually left with is the hours. So you get the hours only, but we need the answer in hours and minutes. So we'll just convert it without using a calculator. We do have a feature on the calculator as well to do this, but 1.8 we do know has 1 hour obviously and 0.8 hour. So now we need to figure out for this 0.8 hour that 1 hour has 60 minutes. How much does 0.8 hour have? So that's x, and the value for x would be just 0.8 times 60, which is going to be 48. So in minutes, 0.8 hours in minutes are actually 48. which means, in other words, this is 1 hour and 48 minutes. So it's going to be 1 hour and 48 minutes. That's your answer in hourly minutes. And that's all for this paper. Hope you understood the paper. Thank you so much.